Good morning and welcome to online teaching session. This is in continuation with the previous video that was on types of reactions, where I taught combination reaction, decomposition reaction. Two types of reactions were discussed. Today in this session we are going to know some more different types of reactions like displacement reaction, double displacement reaction, redox reaction, precipitation reaction and neutralization reaction. So topic name is types of reactions. And in this, the type of reaction which I am going to talk today is displacement reaction. Now, what is meant by displacement reaction? Reaction means it is a chemical change. And displacement reaction, the name itself is informative. Displacement reaction means a reaction or a chemical change wherein a more reactive element will displace the less reactive element of the compound. So, according to concept, the more reactive element displaces the less reactive element of the compound. This is in short the concept. If I take the element which is less reactive than the element of the compound, then this reaction will not take place. Okay. So the more reactive element will take the place of the less reactive element of the compound. This is what going to take place in displacement reaction. This is said to be displacement reaction or displacement change. Now let us see examples that are included in this. First one, iron plus copper sulfate. Here iron is element, copper sulfate is compound. Right? When iron nail is kept in copper sulfate solution, this iron, since it is more reactive than the copper element of copper sulfate, so it will take the place of copper. As a result, we will get iron sulfate plus copper. Right? So here, this is more reactive. Iron is more reactive than copper. If it is written, it will be more clear. Iron is more reactive than copper or copper sulfate. Now let us see example 2. In this example, we are taking the element that is zinc and we are treating it with copper sulfate. Here zinc is more reactive than copper. So we will get zinc sulfate and copper. Means copper is displaced by zinc. Example 3. Here we can take the element like Pb, plumber, and the compound we can take CuCl2, right? Copper chloride or cupric chloride or copper 2 chloride. Here lead is more reactive than copper. So lead will displace copper. As a result, we will get lead chloride plus copper. So here lead is more reactive than copper. In second example, zinc is more reactive than copper. Therefore, the displacement reactions have taken place. If we want to write their physical states, it is not compulsory. If I want, we can write. These elements are metals, so they are solid in state. Copper sulfate here is in aqueous form. So also copper chloride in aqueous form. Iron sulfate in aqueous form, copper is in solid form. Zinc sulfate is in aqueous form, lead chloride is in aqueous form. Right? Copper metal is brown in color. That can be written. Fine. That's about displacement reaction. So in this reaction, mainly there are two substances. Among them, one must be element, the other one compound. The element which is going to participate in this reaction should be always more reactive than the element of the concerned compound. Then only this reaction will take place. So that's about displacement reaction. Now let us see the fourth type of chemical reaction, that is double displacement reaction. Double refers to two. That means there must be two reactants in this reaction, and both the reactants should be in the form of compounds. In previous reaction, one reactant was element, the other reactant was compound. And in this reaction, both the reactants are in the form of compounds. Right? Next. Number 2. Each reactant which is there in the form of compound, that too in aqueous form, undergoes ionization to form ions. Each reactant forms ions. There are two reactants. Out of two reactants, each reactant undergoes division to form ions. Like that, both the reactants which are there in the compound form will undergo change to form the ions, and thereafter they will change those ions mutually. As a result, we will get new products. Right? So these are the important points of this reaction. These points together, if we put, that will become concept. So the reaction wherein both the reactants are converted into ions and then mutually exchange those ions, thereby to form new substances, is called double displacement reaction. So in short, it can be written like this. Both the reactants, in brackets compounds, in aqueous form or aqueous state ions and mutually exchange, thereby to form new compounds. Is known as double displacement reaction. Now let us see example for this. We will take barium chloride. It is a white colored crystalline substance. A pinch of barium chloride will dissolve in water. As a result, we will get aqueous barium chloride solution. So also we will take sodium sulfate and pinch of sodium sulfate, small quantity. In a test tube, we will add little water, we will dissolve. As a result, we will get sodium sulfate in aqueous form. Now in one test tube, barium chloride solution is there. In another test tube, sodium sulfate solution is there. Now what we are going to do here, in the case of both the solutions is few drops of barium chloride solution will add to the other test tube containing sodium sulfate in small quantity. Means 5 ml of barium chloride, 5 ml of sodium sulfate, or 3 ml of barium chloride, 3 ml of sodium sulfate, or 1/4 test tube, which is equal to 5 ml. 1/4 test tube containing barium chloride solution, another test tube that should also have 1/4 of it of sodium sulfate. Now, when one solution is added to the other solution, the change will take place. But here, one thing you need to remember: in aqueous form, each compound undergoes the change to form ions. Like barium chloride undergoes a change to form barium dipositive ion in aqueous form, and chloride negative ions in aqueous form. So also here sodium sulfate will form sodium positive ions in aqueous form, right? 2 sodium positive ions, and then 1 sulfate anion in aqueous form. Now these ions are mutually exchanged according to the concept. Then we will get barium sulfate, right? It is a precipitate, and that too white in color. Precipitate is indicated by downward arrow mark. And then sodium chloride. This will be there in aqueous form, right? So there is about one example wherein the reaction has led to the formation of 2 new products, that is barium sulfate and sodium chloride. Before the reaction is going to take place, we are making aqueous solutions of barium chloride and sodium sulfate separately. And each compound in aqueous form will have its own ions. And these ions will mutually exchange to form the new product. That means positive ion of barium chloride will combine with negative ion of sodium sulfate. Same way, positive ion of sodium sulfate, that is sodium cation, will combine with negative ion of barium chloride, that is chloride anions. So in that way we will get the new products. This is one example. Now we'll move to example 2. In this, we are taking lead nitrate. And the other compound is calcium iodide or potassium iodide. And as in the above reaction, in this reaction, lead nitrate we are taking in aqueous form, potassium iodide we are taking in aqueous form. So when these two react, here also same thing. Lead nitrate will form lead cation and nitrate anion. Potassium iodide will form potassium cation and iodide anion. Thereafter, ions are mutually exchanging. As a result, we will get lead iodide and then potassium nitrate. And here nitrate radical or ion is there 2 times. Here nitrate only once. So to balance it, we will multiply entire KNO3 potassium nitrate by 2. And lead oxidation number or valence is 2 and that of potassium is iodide is 1. So to equalize that, we will multiply this. We'll write PbI2. So this is lead iodide and this is a precipitate, and then potassium nitrate is in aqueous form. KNO3 is potassium nitrate. My entire equation is balanced. So the reactant is lead nitrate and the other reactant is calcium iodide or potassium iodide. And KNO3 is potassium nitrate. Now let us see once again what is meant by double displacement reaction. A reaction wherein the two reactants which are there in the form of compounds will form ions and then mutually they exchange the ions, thereby to form the new compounds. Such a reaction is called double displacement reaction. In such reactions, we will get precipitate. In example 1, barium sulfate is precipitate. In example 2, lead iodide is precipitate. That is about double displacement reaction. Yes, children. Now, let us see fifth type of reaction, that is oxidation and reduction reaction. Oxidation and reduction reaction. Now let us see first what is meant by oxidation. Oxidation. A reaction wherein oxygen is added or hydrogen is removed is called oxidation. So, in short, it can be written addition of oxygen or removal of hydrogen is called oxidation. Same way, let us see reduction. A reaction wherein hydrogen is added or oxygen is removed is called reduction reaction. So addition of hydrogen or removal of oxygen is called reduction reaction. Right? If these two reactions, oxidation and reduction, take place simultaneously, then we call it as a redox reaction. So, oxidation and reduction reaction is also called redox reaction. Now let us see example 1. Copper. If it is exposed to atmosphere, it will not react. But after exposing, if heating is done, means copper metal is heated in presence of air or oxygen, then it gives rise to this compound, copper oxide. Example 2. This copper oxide, when treated with hydrogen, copper oxide when treated with hydrogen, it gives rise to copper plus H2O. Right? And here oxygen is added to this compound, so it is oxidation reaction because oxide is resulted in this reaction. Okay? 2 oxygen atoms. And in second reaction, hydrogen is added to oxygen and oxygen is removed from the cupric oxide. From CuO, we have removed what do you call oxygen. So removal of oxygen is a reduction. So from CuO, oxygen is removed. Since oxygen is removed from CuO, so it is reduction. Whereas in first case, in example to make this way, later in this way. In first case, oxygen is added to copper to form oxide. So in example 1, since oxygen is added to copper, so it is oxidation reaction. Right? Now, these two reactions, oxidation and reduction, simultaneously, if they take place, then it is said to be redox reaction or oxidation reduction reaction. So here, redox reaction means oxidation reduction reaction. So it can be written in this way also. Oxidation reduction reaction. So oxidation reduction reaction means redox reaction wherein oxidation and reduction are taking place simultaneously. Here oxidation and reduction are shown separately. Now let us see when it is going to take place simultaneously, how should it be shown? Right? In this example I am going to take manganese chloride and this I will treat with hydrochloric acid. Right? Manganese chloride is treated with hydrochloric acid. I'll take the other example, simple example that can be understood more clearly, because in this we are going to get more problems. Let me take same example. There is example 2 written here. CuO plus H2. This has given rise to copper and then H2O. Now, CuO has become Cu by losing oxygen. Cupric oxide or copper 2 oxide has become copper by losing oxygen. So the reaction wherein oxygen is lost, a removal of oxygen has taken place, is known as a reduction. So we can label this as a reduction. Right? Next, H2 has become H2O. Hydrogen has become H2O because oxygen is added to H2. That's why it has become H2O. So addition of oxygen. Look at the concept of oxidation. Addition of oxygen is nothing but oxidation. So we will label this as oxidation. So in this reaction, both oxidation and reduction have taken place simultaneously. Therefore, this is an example for redox reaction. Right? So in this, both oxidation and reduction are taking place simultaneously. And here, same reaction I have taken as an example for reduction because I wanted to show the reduction part. Right? And in the same reaction, I wanted to show both oxidation and reduction. So I have labeled in this way. Now, we'll move to example 4. In this, we are taking black colored powder, that is manganese dioxide, and we are adding hydrochloric acid. As a result, we will get manganese dichloride plus chlorine plus H2O. Right? Now, in this, oxidation number of here, manganese dioxide, and we will compare manganese dioxide and MnCl2. We don't have oxygen here. So this can be taken as, what do you call, this part can be taken as an example for the reaction, that is reduction, because oxygen is lost. And at the same time, here in HCl, we have hydrogen and chlorine. And look at Cl2 where we have only chlorine, means hydrogen is removed. So removal of hydrogen is nothing but oxidation. So we will label this part as oxidation. So in this reaction, both oxidation and reduction are taking place. So this is said to be redox reaction. So that's about oxidation reduction reaction. Next, precipitation reaction means a reaction wherein precipitate is resultant. That is said to be precipitation reaction. Or what do you call the double displacement reactions. You have written 2 examples. In both the examples, you got precipitates. So that can be taken as example for precipitation reaction. So that's about the different types of reactions. Thank you, children.